Today we're starting Unit 9, and we're starting with simplifying, multiplying, and dividing rational expressions. So to begin with talking about a rational expression is the quotient of two polynomials. That means you have a polynomial in the numerator and also a polynomial in the denominator. If I gave you some other examples of rational expressions, I could give you an expression of x squared plus 7x plus 12 divided by 2x squared plus 6x. So we have a rational expression by having a polynomial in both the numerator and the denominator. Another example could be something a little more basic. We could have something like 7x plus 5 divided by x. Of course, I could continue the list forever, but in general, a rational expression has a polynomial in both numerator and denominator locations. So a rational expression is in simplest form when its numerator and denominator have no common factors. In order for the simplified rational expression to be equivalent to the original rational expression, domain restrictions must be defined. All right, we're going to start by simplifying a rational expression, and I typed out the steps for you just to save some time. So the first step to simplifying is to factor each polynomial, meaning you factor the numerator and you factor the denominator. The second step is to identify domain restrictions by setting each factor in the denominator equal to 0 and solving for the variable. And the third step is to divide out the common factor or factors and identify the domain restrictions, which are the excluded values. Let's take a look at example number 1. So if we follow the steps that I listed above, the first step is to factor both the numerator and the denominator. Recall that when you factor, you have to start by looking for a GCF, which this numerator has. So this numerator right here has a GCF of 3. I'm going to factor out a GCF of 3, and left over is going to be x plus 1 in my numerator. In the denominator, I have to look at x squared plus 6x plus 5. And I'm thinking to myself, what two factors multiply to 5 and add to 6? And that's going to be x plus 5 times x plus 1. If you still need to do out the entire factoring process off to the side, which is what I'm about to write, you can do that. You're going to notice in my note sheet I skip ahead to the factoring solution because we've been factoring since the beginning of this school year. So I'm hoping that everyone's at a good place of factoring. But feel free to write out all of the steps like I am doing over to the side of the paper here. And if you need any help with factoring, please let me know. I can forward you some videos and some extra practice. Once you have the numerator and the denominator in factored form, you have to identify restrictions by setting the denominator equal to 0. So I'm going to take both x plus 5 and x plus 1, and I'm going to set them equal to 0. When I set x plus 5 equal to 0, I have a restriction, and because it's a restriction, I'm actually going to use a not equal sign, telling me that x cannot equal negative 5. Because if x equals negative 5 and I substitute it back into this expression, I would end up with 0, and you cannot have a 0 in the denominator. So we need to eliminate that value. If I set x plus 1 equal to 0, I have a restriction of x equals -1. That means if I substitute -1 back into the original equation, I'm going to end up with a 0 in the denominator, which again, we cannot have. So these right here are called your domain restrictions. And in parentheses, I'm going to write excluded values. You'll see me call it both things, so make sure you know it's the same term, or it's the same step. So far, we've completed step 1, which is factor. Then we completed step 2, which is to identify restrictions. And next we have step 3, which is to divide out any common factors and list your final answer in simplified form with restrictions. So if we look over here at our original problem, the only common factor that we have is x plus 1. So we can eliminate x plus 1 from both the numerator and the denominator. This leaves us our final answer of 3 divided by x plus 5. And then I like to just list my restrictions as x cannot equal -5 or -1. So I just list them off to the side, just like that. And this is what my final answer looks like, with my domain restrictions listed off to the side. Remember, those domain restrictions are values that would create a 0 in the denominator, which we do not want. And that was step 3. Now let's take a look at number 2, which is definitely a more complex problem. We have a numerator of 3x squared minus 25x plus 50 divided by 9x cubed minus 45x squared. So to start with the numerator, I'm going to factor this up here. This is a little bit of a longer factoring problem, so I want to make sure I give myself plenty of room so I can write out all of the steps. If I multiply a times c, that would be 3 times 50, which is 150. So I need the two terms that multiply to 150 and the same two terms that add to equal -25. This is going to be -15 and -10. So now I can rewrite my equation or expression as 3x squared minus 15x minus 10x plus 50. Group the first two terms, group the second two terms. 3x, left over is x minus 5. -10, left over is x minus 5. We have x minus 5 times 3x minus 10 as our factored form. This here is our factored numerator. Next, I'm going to factor our denominator, and then I'll write them out as a single fraction. So I have 9x cubed minus 45x squared. Recall that the first thing you always check for is a GCF. This one does have a GCF of 9x squared. When I take that GCF out, I'm left with x minus 5. And that is my factored denominator. So now that I have both my numerator and denominator in factored form, I can rewrite this expression as x minus 5 times 3x minus 10 divided by 9x squared times x minus 5. Okay, this was step 1. This was all for the factoring part. Step 2 is to identify your domain restrictions, which means I need to take this denominator and I need to set it equal to 0. So if I set 9x squared equal to 0, divide both sides by 9, take the square root of both sides, but either way it's equal to 0, so x cannot equal 0. There's one of your restrictions. The other restriction comes from when x minus 5 is set equal to 0. That gives you a restriction of x cannot equal positive 5. So these restrictions are the values that would create a 0 in the denominator, which we cannot have. This would be step 2. For step 3, we need to identify if there's any common factors and we need to eliminate them. So the only common factor that we have is x minus 5. I can eliminate x minus 5 in both the numerator and the denominator. And that gives me my final answer as 3x minus 10 divided by 9x squared, with my restrictions that were found in step 2, which are x cannot equal negative 5 or 0. And when I list my restrictions, I always list the smallest number first. That's how I identify how this list is written. This entire piece is my final answer. Okay, please follow along as I complete the on your own section. So for the next section, we're multiplying rational expressions, which is almost identical to simplifying rational expressions, except for this time you have maybe 2 or 3 fractions, and you have to complete the simplifying for the whole entire problem. So to read through the directions quickly, the first couple steps, actually all the steps are the same. This time you need to factor all numerators and denominators. Step 2 is to identify domain restrictions of all denominators. Step 3 is to divide out your common factors. Step 4 is to multiply the remaining numerators and multiply the remaining denominators. Be sure to include your domain restrictions in your final answer. This note is important. This is going to be how I'm grading you. So please leave your final answer in factored form. If you type these problems into a generator on your computer, like, I don't know, Desmos or anything that will do it for you, it's going to give you your final answer in standard form. But that is not how I'm checking these. I'm checking to make sure you know how to do it, and I want your final answer in factored form. Number 1, we have x squared plus x minus 6 divided by x minus 5 multiplied by x squared minus 25 divided by x squared plus 4x plus 3. The first step is to factor all numerators and all denominators. So yeah, there's more with this problem, but it's the same exact process as the ones we just went over. Our first numerator is going to become x plus 3 times x minus 2. And the first denominator is not factorable, so it will remain as x minus 5. We are multiplying this by x plus 5 times x minus 5. That is the factored form of x squared minus 25. And our second denominator factors to x plus 3 times x plus 1. So this was step 1. Step 1 is to factor. Step 2, same as before, identify domain restrictions. You have to identify domain restrictions of all denominators. When I identify these restrictions, the first part of my denominator is x minus 5. Set this equal to 0, and I have a restriction that says x cannot equal 5. I have x plus 3, giving me a restriction of negative 3, and x plus 1, giving me a restriction of x cannot equal negative 1. So these three numbers are my domain restrictions. And that's step 2 in the list above. Step 3 is to divide out common factors. Remember that when you're working with fractions and you're multiplying them, you can divide numerator to denominator throughout the entire problem. So I'm going to highlight my factors as I talk about them. The first factor I can eliminate is x plus 3. I have a value of x plus 3 in both the numerator and the denominator. So I can get rid of that value. The next value I can get rid of is x minus 5. I have a value of x minus 5 in both locations as well. Notice how it does not matter which fraction it is, it just has to be numerator to denominator. I don't have any other common factors, so I can write my final answer, again, in factored form, not in standard form, as x minus 2 multiplied by x plus 5 divided by x plus 1. And I have domain restrictions of x cannot equal negative 3, negative 1, or 5. Okay, to explain my answer a little bit further on this one, when you are multiplying fractions, you don't need to create a common denominator. You don't have to do anything besides multiply straight across. So once you get rid of your common factors, you multiply all remaining numerators. Just multiply them together. And then you multiply all remaining denominators. Multiply them together. That's going to give you your final answer, which is what I wrote down here. So multiplying fractions or multiplying rational fractions is the same as just multiplying basic fractions, where you multiply your numerators and multiply your denominators. Just make sure that you leave your final answer in factored form. Okay, and for the last example, we are dividing rational expressions, which again, very similar to the other two that we've gone over. There is an extra step here. Oops, I actually just realized I numbered them wrong, so it's actually 5 steps. The first step is this is actually a new step, so the first step is to multiply by the reciprocal. Multiplying by the reciprocal means to change the division symbol to a multiplication symbol and flip the second fraction. I've heard students say that they're taught in middle school to remember the saying of keep, change, flip. I don't generally say that, but if that rings a bell to anyone, that could be helpful for you. After you do step 1, the rest of the steps are the same, just about. Step 2 is to factor all numerators and denominators. Step 3 is to identify domain restrictions. There is an addition here. It's of all denominators, including the original denominator of the second fraction. So you do have to include an extra part there, and you'll see when we go through the example. You're going to divide out common factors, and you're going to multiply the remaining numerators and denominators, just like we did in the multiplying problem above. Please leave your final answer in factored form. Number 1, we have 2 minus x divided by x squared plus 2x plus 1 divided by x squared plus 3x minus 10 over x squared minus 1. So the second fraction. This fraction right there is what you have to multiply by the reciprocal. So we are going to rewrite this as 2 minus x divided by x squared plus 2x plus 1 multiply. We're going to flip the second fraction. So we're multiplying this by x squared minus 1 divided by x squared plus 3x minus 10. At that step, all I did was flip the numerator and the denominator. Also, note that you are changing your division symbol to a multiplication symbol. After you complete step 1, which is multiplying by the reciprocal, we do the same thing that we have been doing. You factor all numerators and all denominators. There is one thing to notice for this numerator right here. This is not in standard form, which isn't something we're typically used to seeing. So I'm going to rewrite this as negative x plus 2. And then notice that you are never supposed to have a negative as a first term. So when I'm factoring this expression, I'm actually going to factor out a GCF of negative 1 on this first expression. That gives me negative 1 multiplied by x minus 2. That's my first numerator. I know that's a little tricky, so you might need to rewatch that part of me explaining that. I just converted to standard form, and then I factored out a GCF of negative 1. My first denominator factors to x plus 1 times x plus 1. Multiply by the second numerator factors to x plus 1 times x minus 1. And the last denominator factors to x plus 5 times x minus 2. This is the second step listed above, and the second step says to factor. Now the third step is to find your domain restrictions. However, your domain restrictions are your numerators, but when you're dividing, so when the original problem is division, you also have to include your original denominator. So we have to find everything I just highlighted in gray as a restriction. If you have any duplicate values, you do not need to list them twice. So for example, right here, we have two of the same factors. I am just going to list this as x plus 1, which gives me a restriction of x cannot equal negative 1. X plus 5 gives me a restriction of x cannot equal negative 5. X minus 2 is a restriction of x cannot equal 2. And then this numerator. So here we have a factor of x plus 1, but we already actually listed that down here. So I'm not going to relist that. The only thing I need to list is my value of x minus 1 for my domain restriction. So I'm going to list that over here, giving me a restriction that x cannot equal positive 1. So these four values are my domain restrictions. Also called excluded values. That would be step 3. And now I can go ahead and I can eliminate any common factors. So I see that I have a common factor of x minus 2. I can eliminate that factor. I see that I have a common factor of x plus 1. I can eliminate one of those. Make sure you only do one numerator to one denominator. And it looks like that's it. So now I need to multiply my remaining numerators and multiply my remaining denominators. So left over in the numerator is negative 1 and x minus 1, giving me a numerator of negative 1 times x minus 1. Left over in the denominator is x plus 1 times x plus 5. I have domain restrictions of all denominators listed from smallest to largest would tell me that x cannot equal negative 5, negative 1, 1, or 2. Okay, be absolutely certain that your final answer is in factored form and not standard form. That is what I'm checking, so please follow the directions. Okay, I'll go ahead and do the on your own section if you want to follow along. Please let me know if you have any questions, and have a great day.